Hi, and welcome to Dr. V's AP Chemistry podcast. Today we're talking about net ionic equations. It's really important that AP Chemistry students are able to do this really well. What I'd like to accomplish in this webcast is to use the reactants that are given in the reaction and the class of reaction to predict the products. And from that, we'll write a complete molecular equation showing the products. We'll then write a complete ionic equation, figure out the spectator ions, and use that to write a net ionic equation. As I said, this is an essential skill for all AP chemistry students, all college level chemistry students. It's a must do. So let's look at the situation. A solution of silver nitrate is combined with a solution of sodium phosphate. Well, the first thing we need to do is write out the formulas of the reactants. Silver nitrate is AgNO3, the sodium phosphate is Na3PO4. They're both in solution, and it's okay in these situations to assume that all the solutions are aqueous, unless you're told otherwise. The next thing we need to do is start thinking about the products. Now, if you look at the two reactants, they're both ionic compounds. So we're going to get a double displacement reaction and make two new ionic compounds. So the products end up being silver phosphate and sodium nitrate. Now you do want to pay attention to your ion charges, right? The silver is +1, the nitrate's -1, that's why they were in a 1-to-1 ratio. The sodium is +1, and the phosphate ion is -3. So when we switch partners and the silver ends up with the phosphate, we will end up with 3 silvers for the phosphate. So it's Ag3PO4. And the sodium and the nitrate ions will come together in that 1-to-1 ratio. It's really important that this formula writing piece is accurate. The next thing we need to do is balance the equation. We do have to have equal numbers of each kind of atom on each side. So we need 3 silver nitrates to react with the sodium phosphate to make the silver phosphate, and then we'll make 3 sodium nitrates. This is a complete molecular equation. I've got all the formulas of all the reactants and products just together as they would switch places in the reaction. The next thing we need to do is write a complete ionic equation. In order to do that, we need to show all the aqueous solutions as dissociated ions if they dissociate to an appreciable degree. So the silver nitrate and the sodium phosphate and the sodium nitrate here all fit into that category. We need to separate those because those will completely form ions in solution. They're very soluble. All right. The silver phosphate is a precipitate, and it's going to stay together in solution. It will actually fall to the bottom. If you don't know your solubility rules, this is a good time for you to sit down, take some time and memorize them. You should know that all common nitrates are soluble. You should also know that all the group 1 metal cations form typically soluble compounds. And so that means that the sodium and the nitrate ions are going to separate. All right. And so we have 3 silver ions and 3 nitrate ions, remember the balanced equation, reacting with 3 sodium ions and a phosphate ion to make the solid silver phosphate, which is a precipitate. It's going to fall to the bottom. We'll have 3 sodium ions and 3 nitrate ions. This is our complete ionic equation. It shows all the species in their actual form. All right, but the next thing we need to do is to cross out the spectator ions. By spectator ions, we mean they're in the same form on both sides of the equation. All right, so if you look at this, we have nitrate ions as reactants and as products. We have sodium ions as reactants and as products. Those are our spectators. And so our next step is to remove them from the reaction. All right, we cross them out. All right, they're in the same form. They're really not doing anything. And so the advantage of the net ionic equation is that it really shows the species that are undergoing a chemical change. What's left is the net ionic equation. You don't really have to rewrite it separately, but you may find it helpful to do that. The other thing I wanted to point out is that states of matter, I've written them throughout this webcast. They're not necessarily required. If you find them helpful, do so. But if you're in a time situation, if it's a test situation, you may find that you don't want to include the states of matter if it just slows you down. And like I said, this is something you really need to be able to do. So one thing to keep in mind when you're doing a net ionic equation for a double displacement reaction like we had in this webcast is that the formation of the precipitate, right, from its ions is really what the ionic equation is about. So that might be a shortcut for you to be able to do it more efficiently. Great. We'll talk another time.